Assalamualaikum. So we go to the plastic bags. So what is a plastic bag? Plastic bag is a lightweight, flexible packaging product commonly used for carrying, storing, and protecting goods. It's widely utilized in retail stores, supermarkets, food packaging, industrial application, and household activities due to inconvenience, durability, and low production costs. So, is definition of plastic bags. So we go to the material use. So we have the three. First, high density polyethylene. First, is strong and lightweight. Second, we have low density polyethylene (LDPE). This provides better transparency. And third is high density polyethylene. We offers improved strength and puncture resistance. Next, we go to usage and relevance. So first, cost effective, low manufacturing and transportation costs. Two, water resistant, protect products from moisture and rain. Three, versatile, suitable for retail, industrial, medical, and agriculture and domestic application. Five, durable, capable of carrying various loads without tearing.
Assalamualaikum. My name is Muhammad Akmal Zarfan bin Norisham. My matrix number is 2250199. Today, I would like to explain why we choose SDG12, responsible consumption and production in relation to plastic bag. We selected this SDG because plastic bags are one of the most common single-use products in our daily lives. They are convenient, but they are made from the non-renewable fossil fuel and can take thousands of years to decompose. As a result, they contribute significantly to environmental pollution and waste accumulation. A real-life problem that many communities face in improper disposal of plastic bags. According to United Nations Environment Programme, plastic waste can block drains, waterways, increasing the risk of flooding during heavy rainfall. This affects transportation, damage property, and disturb daily activities. Reducing the use of plastic bags helps us to achieve SDG12 by encouraging responsible consumption instead of relying on single-use plastics. People can switch to reusable bags, reduce waste generation, and support recycling practice. This also improves productivity in several ways. For example, cleaner environment mean fewer disruption caused by clogged drainage system and floods. Other than that, business spend less money on waste management and cleanup. Workers and students can travel more efficiently but when infrastructure is not affected by plastic pollution. In addition, resources can be used more effectively instead of being wasted on producing disposal products. In short, choosing SDG12 highlights the importance of reducing plastic bag consumption, protecting the environment, and creating more productive and sustainable society for future generations.
So now let's talk about life cycle assessment of the plastic bag. So first we have raw material extraction, second manufacturing and processing, third usage stage, and lastly end of life stage. So let's start at the very beginning of the life cycle, the raw materials. While we see plastic bags as everyday items, they are essentially solidified fossil fuels. They are made from chemical derivatives extracted directly from crude oil and natural gas. The major environmental concern here is twofold. First, we are depleting finite, non-renewable planetary resources. Second, the drilling and extraction process itself causes massive habitat destruction and frequently leads to invisible methane leaks, which severely accelerate global warming. So, net in a manufacturing phase, those raw fossil fuels are transported to chemical plants where they undergo highly energy intensive process like chemical cracking and polymerization. This turns the raw gas into tiny polyethylene plastic pellets. To actually shape the bag, factories consume massive amounts of electricity and thermal energy to melt down those pellets and blow them into thin plastic films. This stage generates heavy fossil of CO2 emission and introduces industrial waste like microplastic pellets into local ecosystem. So, Now, we reach the usage stage, which present a striking environmental paradox. Because plastic bags are incredibly lightweight and waterproof, they require very little fuel and resource consumption to transport in bulk to retail stores. However, the real problem is the frequency of use. Despite the energy it takes to make them, the vast majority of these bags are single use. On average, a plastic bag is used for just 12 minutes before being thrown away, making the resource to utility ratio incredibly inefficient. So finally, we look at the graph of the cycle, the end of life stage. A common misconception is that plastic bags are easily recyclable. In reality, they are functionally non-recyclable in standard facilities because the thin film easily tangles and clogs sorting machinery. Because of this, most bags end up in landfills where they take up to 500 years to decompose or they are incinerated, releasing toxic ash and greenhouse gases. Worst of all is environmental leakage. When they blow away into our oceans, they do not disappear. They fragment into dangerous microplastic that permanently contaminate marine life and the human food chain.
So, alternative material. First, use recycled plastic instead of new plastic. Second, use recyclable materials such as aluminum or steel. 3. Choose biodegradable materials where suitable. 4. Avoid materials that are difficult to recycle. Next is improving product lifespan. Number one, use stronger and more durable materials. Second, design for easy maintenance. 3. Allow damaged parts to be replaced. Number 4, improve product reliability. 5. Provide proper user guidelines for longer using. Use reducing energy usage. Use low power components, improve system efficiency, reduce unnecessary energy loss, add standby or automatic shut off mode, and lastly use renewable energy sources if suitable. Next, producing waste generation and circular economy. Number one, minimize material waste during production. Second, reduce single-use component. Third, use recyclable packaging. Fourth, separate waste according to material type. And lastly, encourage repair instead of disposal. So, design, use, maintain, repair, reuse, recycle, and remake. Thank you.
For conclusion, sustainability is about smarter choices, better materials, reduce waste, reusing products, save resources, and using less energy cut costs. Longer product life means fewer replacements and recycling turn rubbish into valuable resources again. This simple step can protect our planet and our future. That's all from us. Thank you.